Hey mathematics learners, welcome to Distance Learning with Lee, where I make learning mathematics super easy. So on today's video tutorial guys, we are going to be tackling question 4.2 from the grade 12 mathematical literacy paper 2 that was written in June 2023. And question 4.2 guys, it deals with measurement. All right, like I've mentioned, paper 2, like a huge chunk of paper 2 deals with measurements. So if you struggle with measurement, if you struggle at just thinking about surface area, thinking about volume in a practical way, you will struggle with this paper. So you need to start to actually think about, okay, what does it mean when I'm calculating surface area practically? What is this question asking me to do? Okay, what is my focus area when I'm calculating the surface area of this particular object? Okay, or shape. So you need to be very careful when dealing with these questions. You need to focus at what the question is asking you. Don't just be like, oh, the formula for surface area is this and this and this, right? Without actually understanding what the question is asking you to focus on, right? So it covers volume, surface area, and also conversions. Okay, so please make sure that you watch the entire video tutorial. Please make sure that you are subscribed. Please make sure that you give all these video tutorials a huge thumbs up, guys. Let's help the channel to reach 50,000 subscribers by the end of this year. Please help the channel reach that goal, right? And yeah, guys, without any further ado, let's get started with today's video tutorial. So like I mentioned in today's video tutorial, guys, we're going to be tackling question 4.2. And question 4.2 deals with measurements. And the subtopics in this question is calculating surface area, calculating volume of a cylindrical shape, volume of a rectangular shape, surface area of a cylindrical shape, but just focusing on the inner part of this cylindrical shape. So please make sure that you pay attention. All right, so let's get started. So it says the owners of the holiday resort plan to build a cylindrical pool. The pictures below show the existing rectangular swimming pool and a cylindrical swimming pool which the owners plan to build at the holiday resort. Okay, so this is the cylindrical pool. We are given the diameter of the pool and the depth, how deep this pool is. We are given the rectangular pool, right? And the dimensions or the inner dimensions of the pool for the cylindrical pool. The diameter is 7 meters, the depth is 1 meter, and the tiles. Okay, we are told that to get the area of one tile, okay, it'll be 20 centimeters multiplied by 20 centimeters. Okay, so we can see that this tile has a shape of a square. Okay, and we know that in one box we are given 16 tiles. Okay, then we are also given the inner dimensions of this rectangular pool. The length is 6.2 meters, the width is 3.25 meters, and the depth is 1.65 meters. We are told to note, to convert from meters cubed to liters, okay, 1 meters cubed is equal to 1,000 liters. So we can use this equation to help us when we have to do our conversions from meters cubed to liters. Okay, then question 4.2.1, obviously we need to use the information above to answer the questions that follow. Give one reason why you think the cylindrical pool is designed for small children. Okay, so here you can just look at the cylindrical pool and you can just look at the rectangular pool. Is there anything that you're noticing, right, in terms of why the cylindrical pool could be better for small children? Do you guys realize that the depth for the cylindrical pool is 1 meter? However, the depth for the rectangular pool is 1.65 meters. Okay, so we can see that now just by looking at the depth, we see that the cylindrical swimming pool is not too deep. Okay, so then that is what would make it more suitable for children. Okay, so looking at the depth, we see that the cylindrical swimming pool is not too deep. So that is why then we can say that this pool is designed for small children. Okay, so we can say that the depth of 1 meter is shallow. It's not too deep. Okay, so we can just write that. Okay, the depth of 1 meter is shallow, or we can say that it's not too deep. Okay, let's have a look at the next question. Question 4.2.2. Okay, It says, explain the meaning of capacity, okay, of a swimming pool. Remember, guys, when we're calculating volume, okay, I explained what it means practically when we are calculating the surface area, right, of an object. When we're calculating surface area, we are just trying to determine what is the area of all the surfaces of the object. Okay, what is the total area of all those surfaces? When we are calculating volume, okay, we are trying to determine how much can a particular object hold. Okay, so if we were to just focus on the swimming pool, okay, if we had to calculate the volume of this cylindrical swimming pool, we are basically trying to determine how much water can this cylindrical swimming pool take. Okay, how much space is enclosed within that cylindrical swimming pool? If we want to calculate the volume of this rectangular swimming pool, we just want to determine how much water, okay, maximum water can I pour into this rectangular swimming pool. Okay, how much water at maximum can this pool take? So that is basically what we're doing in this case. We are trying to determine how much water, maximum water, can these two swimming pools take. So that is what we're talking about when you're talking about volume, when you're thinking about it practically in this context. Okay, so please have that in mind when we're now answering these questions. Okay, question 4.2.2, explain the meaning of capacity of a swimming pool. So when we're talking about a capacity of a swimming pool, we are basically talking about what is the maximum amount of water that that swimming pool can take. Okay, when we talk about capacity, what is the maximum? How much water, maximum water, can this swimming pool hold? Okay, so we can basically write that down. The pool can hold, or that the pool can hold. Okay, right. So we're done with question 4.2.2. Let's go to question 4.2.3. It says, calculate rounded to the nearest liter. So we want to have whatever answer that we get, it needs to be a whole number. Okay, the difference in the volume of the two swimming pools. Okay, so what do you think we can do to approach this question? Okay, the first thing that we need to do, because we want the difference in the volume of the two swimming pools. Okay, so that means that we want to find, if we're talking about the difference, okay, the difference is equal to the volume of one pool minus the volume of the other pool. Okay, so that is basically where we are trying to get at. Okay, so the first thing that we need to do, we need to determine what is the volume of the cylindrical pool. Okay, what is the volume of that pool? Then we need to determine what is the volume of the rectangular prism. Okay, and then from there, right, find the difference of these two pools. Okay, however, the answer that we get, it needs to be in liters. Okay, so now what is going to guide us in terms of getting to our final answer? Okay, we already know that we are given an equation that we can use to help us convert our final answers into liters. So we already know that we're given that 1 meters cubed is equal to 1,000 liters. Okay, so that tells us that when we are calculating our volume, the units that we need to use are supposed to be meters. Okay, so we're going to start off by calculating the volume of the cylindrical pool. Then we're going to calculate the volume of the rectangular pool. Then we're going to find the difference between those two volumes, and then we're going to convert our answer to liters. Okay, so let's start. Okay, so let's start off with calculating the volume of the cylindrical. They've made our lives super easy because we are given the formula. Volume of a cylinder, right, is equal to pi, which is that 3.142, multiplied by radius squared, multiplied by the depth. Super easy here because we are just substituting the values that are given to us. Okay, what is the radius? So here you realize that we are not given the radius. However, we are given the diameter. So how do you find the radius? if you are given the diameter. So we know that to get the radius, if you're given the diameter, it's just the diameter divided by 2. Okay, so where we see the radius, we are just going to put that 7 divided by 2, and that will give us now the radius of the cylindrical swimming pool. Okay, so I'm going to write again that 3.142 multiplied by the radius is the diameter divided by 2. That's 7 divided by 2 all squared multiplied by what is the depth of the swimming pool? It's 1 meters. Okay, so I just forgot to write my units here. Okay, so it's 7 divided by 2. It's 7 meters divided by 2 all squared multiplied by the depth of 1 meter. Okay, so if you punch this into your calculator, you will get 38.4895 meters cubed, because the answer that you're going to get here is going to be in meters squared multiplied by meter. So therefore the volume is going to be 38.485 meters cubed. Also, we know when we're calculating volume, we are working in 3D, right? In this case, then, if we're working in 3D, whatever answer that we get, okay, it's going to be in meters cubed, millimeters cubed, centimeters cubed, kilometers cubed, because we are working in 3 dimensions. Okay, so let's calculate the volume of the rectangular pool. Okay, we are still given the formula that we're supposed to use to calculate the volume of the rectangular pool, or of the rectangular prism, right? It's length times width times depth. Okay, then we go to what is the length? It's in meters, meters, meters. So we're happy with that. So what is the length? The length is 6.2 meters multiplied by what is the width? Is 3.25 meters multiplied by what is the depth? Is 1.65 meters. Okay, so 6.2 multiplied by 3.25 multiplied by 1.65, okay, will give you 33.2475, right? Meters multiplied by meters multiplied by meters is meters to the power of 3. Okay, so remember, whatever answer that you get, it needs to be in the units of measurements, meters squared in this case. Okay, so we found the volume of the cylindrical pool, we found the volume of the rectangular prism pool, and now we can find the difference. Okay, so therefore the difference in the volume is equal to, you're going to take the bigger units minus the smaller, the bigger value minus the smaller value. Okay, so it's going to be that 38.4895 meters cubed minus 33.2475 meters cubed. Okay, if you punch that into your calculator, you will get the difference in the volume between these two pools is 5.242 meters cubed. But remember, the question is asking us to determine what is the difference in the volume to the nearest liter. Okay, so we can't just leave this answer in meters cubed. We still need to continue. So for us to continue, that basically tells us that we need to then convert, okay, these meters cubed to liters. And what are we going to use to convert? We're going to use that 1 meters cubed is equal to 1,000 liters. Let us write that down. We know that 1 meters cubed is equal to 1,000 liters. Already when you guys see me writing this equation down, you know we are going to multiply by what we want, and we're going to divide by what we have. Multiply by the units that we want, divide by the units that we already have. Okay, so we're going to take the difference in the volume that we already have of 5.242 meters cubed. That is what we already have. That is what we want to convert to liters. Okay, therefore we multiply by what we want. We want whatever units, we want our units to be in liters, so we're going to multiply by 1,000 liters, and you're going to divide it by what you have, which is our units in meters cubed. Okay, so 1 meters cubed. Okay, so someone was already going to see that this is just the same as just taking that 5.242 meters cubed and dividing it, meters cubed, right, and timesing it by 1,000 liters, okay, to get to the final answer. But I prefer using this method because I want to show you that the units are cancelling. Do you see that? Meters cubed cancel. Whatever answer that you're going to get, it will be in liters. Okay, so when you punch that into your calculator, you'll get a final answer. If you take 5.242 multiplied by 1,000, you'll get a final answer of 5,242 liters. Okay, so therefore the difference in the volume of these two pools, right, is 5,242 liters. All right, cool stuff. All right, let us have a look at question 4.2.4. It says the total inner surface of the cylindrical pool will be tiled. Okay, an additional 10% tiles were purchased. You may use the following formula, okay, which is surface area of an open cylinder. Please take note of this. Now we're calculating the surface area of an open cylinder, okay, not a closed cylinder. Okay, so this cylinder, right, if we had to draw it in 2D, okay, because we've got, this is the cylinder that they're talking about. Okay, however, in this case, at the top there it's open. So if I had to now draw this in 2D and open this up, how would it look? Okay, it would look like this. You'd have that rectangle there, okay, and you'd have that circle there. Okay, so when we are basically trying to determine the total inner surface area of the cylinder, we are saying that now what is the area of that surface and what is the area of that surface. So basically how they got to that formula, they took the area of a circle, right? And how do we calculate area of the circle? Okay, it is pi times r squared, and then they took the area of this rectangle. But remember, the outline of this rectangle is actually the circumference of this circle. Okay, so here, what does that mean? How would you get the circumference of this rectangle? Right? So to get that length, you use the circumference, which is 2 times pi times r. That is how we'll get that length there. Okay, and then how would we get then the width of this rectangle? It is just the depth. So that formula, how they got to that formula is basically they've opened up this cylindrical pool, and we are just focusing on the inner area. Okay, so when you open it up, even if you were to take a paper, right, an A4 paper, and you were to roll it, it will be a cylinder. But if you were to open it up, right, it'll be a rectangle. So that distance there is that circumference of the circle, because it is that outline of that circle, and then therefore the depth, right, is just then the width of that. Okay, so what did they do then? They just calculated the total surface area, which is they basically took the area of this circle of pi times r squared, area of the circle, plus, not multiply, plus the area of this rectangle. But in this case, the length is actually equal to the circumference, which is 2 times pi times r multiplied by depth. And then what did they do here? They just saw that there was a common factor of pi and r, and therefore you would be left with here r plus 2d. Okay, so that is how they got to that formula there. Okay, that is how they got to that formula there. But I mean, it's not important. But for me, I feel like it's important that you guys see where these formulas come from. Okay, so now that we understand where that formula comes from, we can apply it now because we understand physically what is happening with this formula. Okay, so let's have a look now at the questions. Question 4.2.4a says, give one reason why additional tiles were purchased. Remember, they are saying that here an additional of 10% tiles were purchased. So what could be the possible reason as to why they bought those additional tiles? So, I mean, when you're renovating, mistakes happen. Where if you were to buy an exact amount of boxes, what happens if maybe they drop a tile? Okay, so now when they buy an additional amount of tiles, that is just so that you can even just cover for the breakages. Or you can say to accommodate the cutting of the tiles. Or you can say for curved surfaces. Or you can say to keep spares for later use. Okay, so any of those reasons will be accepted. Okay, to cover for breakages. So that's the reason that I'm going to use. Okay, let's have a look at the next question. Question 4.2.4b. It says the tiler states that he requires more than 100 boxes of tiles to complete the tiling. We need to verify showing all calculations whether this statement is correct. Okay, so before we can even go to the part where we want to calculate how many boxes are used, the first thing we need to do is we need to determine what is the area, surface area that has to be tiled. Okay, and we were told that the area or the surface area that has to be tiled is the total inner surface of the cylindrical pool. So the first thing that we want to determine is what is the inner surface area or the total inner surface area of the cylindrical pool. And we're going to use this equation that is given to us to help us determine that inner surface area. Okay. Another thing that you guys also need to be aware of, right? When you are calculating now the surface area of this inner cylindrical pool, you need to take into consideration that the dimensions of the tiles are actually given to us in centimeters. Okay, we need to first determine what is the surface area or the inner total surface area, and then we need to determine how much area one tile covers. Okay, and then from there, right, you'll see that we need to now work with centimeters squared and centimeters squared. Okay, so that is why in this case we need to convert these meters into centimeters. Okay, so that we will get the inner surface area or the total inner surface area of the cylindrical shape, right, in centimeters squared. Okay, so let's do that. Okay, I'm just going to do the conversions, okay? So please keep in mind that diagram that we always draw when we are doing our conversions, okay? In this case, we want to convert the 7 meters and we want to convert the 1 meters to centimeters, okay? So remember, when we're moving from centimeters to meters, okay, we are moving from the smaller units to a bigger unit. Okay, so in this case we are multiplying by 1,000. Here we multiply by 100, but here we want to move, we want to move from meters to centimeters, so we have to multiply by 100. Okay, so in this case we need to multiply that 7 by 100. We need to multiply that 1 by 100 to convert these units of measurement to centimeters. So we've converted these units into centimeters. Now we're more than ready to substitute into our formula. We know that the total surface area of the inner part of the cylindrical shape is equal to, we're given 3.142 multiplied by the radius, multiplied by radius, plus 2 times depth. And I showed you guys how they got to this formula. Okay, then all that we need to do, we are going to substitute. Remember, to get the radius, okay, radius is equal to the diameter divided by 2. What is the diameter? Okay, 700. centimeters divided by 2. So you'll find that the radius is actually 350 centimeters. So we can just substitute the 350 centimeters where we see radius, okay? Times 350 centimeters multiplied by, open brackets, 350 centimeters plus 2 multiplied by, what is the depth? 100 centimeters. Nice and easy, okay? So let's start off with just getting the answer for this part, okay? 3.142 times it by 350 is equal to 1099.70 centimeters multiplied by, what is that part there? Okay, 350 plus 2 times 100. That is going to give us 550 centimeters. Okay, therefore, if you punch this into your calculator, you get 604,835 centimeters squared. Okay, because centimeters multiplied by centimeters is centimeters squared. But also just a key or a way for you to remember what the units of measurements are for surface area. The keyword is area, so it's centimeters squared, millimeters squared. So the unit of measurement for surface area is unit squared. Okay, now let's determine now what is the area that is covered by one tile. So remember, we were given the dimensions for one tile, right? And we said that it's a square because we've got 50 centimeters and 50 centimeters. So the length of this tile is 50 centimeters. And the length and the breadth of this tile is 50 centimeters. Or the length and the length is 50 centimeters, okay? So to determine the area that is covered by one tile, how do we calculate the area of a square? It is length times length. Okay, so if you take that length multiplied by that length, so 50 centimeters multiplied by 50 centimeters, how much do you get? Sorry, it's actually 20 centimeters, not 50. Okay, so it's 20 centimeters multiplied by 20 centimeters, right? That will basically give us the area that is covered by one tile. Okay, how much area is just covered by one tile on the floor? Okay, so if you take 20 multiplied by 20, you'll basically get 400. Okay, then centimeters multiplied by centimeters is centimeters squared. And remember, we are calculating area, so the unit is centimeters squared in this case. Okay, so now we know the area that is covered by one tile. Okay, in other words, we can just also write it as one tile gives us an area of 400, covers an area of 400 centimeters squared. Okay, so now we want to basically determine how many tiles will we need to cover the surface of 604,835 centimeters cubed. Okay, so in that case, we are basically going to say we want to take that 604,835 centimeters squared multiplied by, we want to determine how many tiles. Okay, do you see what we're doing there? We took the answer that we've basically obtained, and we know that this answer gives us the area that is covered by one tile. That is why I wrote one tile covers an area of 400 centimeters squared. Okay, so we multiply by what we want. We want to determine how many tiles will we need, divided by what you have, which is our units in centimeters cubed, centimeters squared. Okay, divided by what you have. So someone will also see here that it's the same as just saying 604,835 centimeters squared, and you divide it by the area that is covered by one tile of 400 centimeters squared. If you punch this into your calculator, whatever answer that you'll get, it'll just give you how many tiles you will need to cover this inner area of this pool. Okay, so then you will basically get 1512.0875. That's the number of tiles that we need. Okay, if we had to stop here, we would then say, because we are dealing with a real life situation, right, you would then have to round this up and say that, okay, that means that I'm going to need 1,513 tiles. However, we are not going to stop here because the question was basically talking about that an additional of 10 tiles were purchased. So additional to this, we need to add 10% of this amount. So what is 10% of this amount? So we're going to continue, right? So to get the additional tiles, we are just going to take that 1512.0875 tiles multiplied by, because we want 10% of this amount. 10% of this amount. Okay, so that's the same as just saying additional tiles is 10% of that 1512.0875 tiles. Okay, 10% is also the same as just saying 10 divided by 100 of is multiply 1512.0875 tiles. Okay, so whatever amount that we're going to get here is just telling us what the 10% additional tiles are, how much they're going to be. Okay, how many they're going to be. Okay, so 10 divided by 100 multiplied by 1512.0875, you will get 151.20875. So that basically means the total tiles that you'll actually need is going to be that 1512.0875 tiles plus the additional 10% of 151.20875 tiles. Okay, and that is actually going to be equal to 1663.29625 tiles. Now we are not done. Remember, we're working with a real life situation. Okay, so you won't go and say I want 1663.29 tiles. Okay, you want whole tiles, not tile and a halves. Okay, so in this case you want to just round it up. It's going to be 1664 tiles. Okay, so that's the amount, the total number of tiles they will need to basically now tile the inner surface area of the cylindrical shape. So now the tiler stated that he requires more than 100 boxes. All that we've just calculated is the number of tiles. So how do we determine how many tiles, or how many boxes actually we need to get? So remember here, we were told that one tile is actually gives an area of 20 centimeters by 20 centimeters, covers an area of 20 by 20. Okay, and we are told that in a box, so one box contains 16 tiles. Okay, so here it's just telling us that there's 16 tiles in a box. So we can just write that down, that one box contains 16 tiles. So you already know what we're about to do now, right? So we're going to use this equation to help us now convert these 1,664 tiles into how many boxes we'll need. Okay, so what do we have to do? Easy peasy, right? We are just going to take that 1,664 tiles. We want to basically determine how many boxes we'll need, or how many boxes we'll have, or how many boxes we'll buy if we need 1,664 tiles. You multiply by what we want. We want to determine how many boxes. Okay, one box, and you divide it by what you have. We already have how many tiles we have, so it's 16 tiles. Okay, so here someone was also going to see that you just need to take that 1,664 tiles and you divide it by 16 tiles to get how many boxes you will get. Okay, so if you punch that into your calculator, you'll find that you basically need 104 boxes. Okay, so that's the total number of boxes that this person will need. So what does that mean? What was the original statement? The tiler stated he requires more than 100 boxes of tiles to complete the tiling. So we've basically confirmed that he does in fact need more than 100 boxes, because we found that he needs 104 boxes to complete the tiling. Okay, so we can therefore conclude that his statement is valid. Okay, so I enjoyed this question very much. It's your application questions, guys, right? Where you now need to apply everything that you know about surface area, about volume, about tiling. You're thinking about things now in a practical sense. Okay, so I hope you enjoyed this video tutorial. I surely did. Please comment down below, how did you find the video tutorial? Did I make the complex easy for you guys? I mean, the concepts easy for you guys to understand? Let's talk down in the comment section, guys, right? Let's talk. Let's have opinions. Let's have suggestions. What do you guys think? Okay, so that is it for today's video tutorial, guys. In the next video tutorial, we are going to be tackling question 5.1, question 5.2, and question 5.3. And we are finally done with this paper. Then we're going to be going to basically lessons on measurements, okay, on how you calculate area, how you calculate perimeter, surface area, volume, how you do your conversions. I'm going to go into all those concepts in detail. So please make sure that you are subscribed, and please make sure that you share this channel with your friends at school. It will really help them a lot. Okay, so I'll see you guys on my next upload. That is it, guys, and I'll see you guys on my next upload, Distance Learning with Lee, where I make learning mathematics super easy. Bye, guys.